All right. So we always want to do announcements first.
Sure. I remind people that the PostgreSQL is coming up in about a week and a half in Orlando, March 18th through the 21st. Still time to get tickets. I'll be speaking there on the auto vacuum system, besides being at the registration booth. So, yeah.
And then there is stuff you guys here tonight, and I know DNR guys, but super last minute. In the off chance anybody was still interested, you can get free tickets by volunteering, and they are still looking for volunteers, like table monitors, stuff like that.
Yes. Contact Debbie at postgresconf.org.
Yeah, and we had somebody last month who we got them hooked up because Debbie sent that email just like yesterday or the day before. So yeah, we did have somebody from the user group who sounds like they might be heading out that way on a free ticket. So
when you volunteer, the conference is free. You still have to do your own airfare and hotel.
Okay. Other stuff, that's Orlando.
That's Orlando.
Which is this one.
Yes. Debbie, DEBEIE, postgresconf.org.
Yeah.
If you don't get her, you can always do organizers, and that will go to her. I'll get it, and various other people.
Yeah. CC me or what. If you don't have access to me, I'll give you my email address. Copy me on it. That way, if you know boxes or something, I know to send it. Or I'll make sure you get you in touch. So that's Orlando. There were rumors of a PG Saturday event here in Seattle. That is not going to happen, just so you guys know, because I mentioned it last month. The one other thing to mention is, just for folks, most of you probably know this, but if you don't, in May is one other conference that was worth highlighting. It's called pgconf.dev. It is going to be in Montreal, May 13 and 16, and that is kind of like the main conference where people who are working on the internals of Postgres meet up and talk about. For folks who don't know, the timing is very intentional. That conference always happens in the spring, and it happens right about the time when they stamp out sort of like the first beta for what will be the next major version of Postgres. So that is like a lot of the key Postgres core developers will be there, and there'll be a lot of conversations about kind of like what are the final features that are staying in for Postgres 18, which will be coming out this fall. And it's a fun conference to go to. I've been there.
Also, for under the PostgreSQL umbrella, PG Saturday in Dallas will be April 5th, and PG Down Under in Sydney, Australia will be October 17th. It's going to be a one-day conference this year. So that is coming up also.
All right.
And those two conferences you can find on the postgresconf.org website.
Okay. I hope everybody signed in. If you didn't, please do. It's just so we keep track of how many people showed up tonight. You're not going to get notifications. Cameron, right?
Yes.
Have you been out here before? I feel like I recognize those people, but you might not have been. Cool. So just so you know, the meetup.com website is how we send all of our notifications out. If you're not already on it. Cool. All right. Great. You got that figured out then. Okay. Library, we got books. You're welcome to take one, just your name, a little bit of contact info on that clipboard so that if it doesn't come back in a year, I can just check whether you're still reading it or you just forgot. There's a thing called the happiness hint, which are best practices for Postgres. You're welcome to take one, and anybody else. And
I still owe you a Postgres internals book. It's still in my house.
you can owe me a book report. Now you know. I think you do it.
I just needed information about the query processor. I'm done now.
It's a good one though, isn't it? Like, did you get sucked in anymore? Or
A little bit.
actually
Yep.
stay with the query processor part?
Well, I just needed it for the query processing part.
I really enjoy that book. It's a good one. That was Igor Rogov's book, right?
Yep.
Yeah.
The internals one.
Yeah, that's a good one.
By the way, that book you can download as a free PDF also.
Also true. I like the print books, but yeah.
Yeah, I mean, unfortunately, I gave mine away as a drive this last year at the PASS conference. But yeah, it's a very good book.
All right. Then the last thing is bathrooms. If anybody needs to know, they're down there either to the right or the left, both ways. Do you have any more announcements? All right. Then I will introduce Harry, who's our speaker tonight. So Harry is a seasoned software architect and engineer with over 30 years in the IT industry. You said that you spent 20 years at Microsoft in various roles, pioneering technical evangelism and focusing on developer experience. It'd be fun to hear some stories sometime about your evangelism roles, because those are fun. I know a couple people doing that. Today, Harry is an engineer at, how do you say it? DBOS, right?
DBOS.
It is pronounced DBOS. Working on their mission to dramatically simplify the way cloud applications are built, deployed, and secured. And outside of work, I love that you include, I always tell everybody, try and include some outside of work stuff. Harry is a husband and a father, and a beer league hockey player, and an amateur powerlifter.
Thanks very much, Jeremy. Okay. 1 second. There's a slight mistake. 1 second. Yeah, it's me. Yeah, no, I told you I didn't want to use the DeLorean. Yes, I realize it's iconic. It's also overused. This is the second time travel debugger I've built in my career. You'll never guess what pop culture iconography we used last time. Yes, of course, the DeLorean. What else do you got? Oh, that's nice. That's the OG, right? H.G. Wells' Time Machine. Not bad, not bad. What else? The Terminator in 2025? Read the room, dude. No. This is perfect. Bill and Ted. Yeah, this is. I've given you a great story to go along with this. A friend of my wife came to stay with us with her kids. And we were showing them a movie. It was like a movie night. So we showed them Bill and Ted. And there's a bunch of teenagers in the 21st century. I figured they have no idea what a phone booth is. So the first time the time traveling phone booth appears on screen, I'm like, hey, who knows what that is? Oldest daughter, side-eyes me. Of course I know what that is. That's a TARDIS. So can we get a slow clap for the mom, please? Teaching them right. But we're not here to talk about time travel in pop culture. We're here to talk about time travel in Postgres. So start with a show of hands. How many people here have ever used the native built-in support for time travel queries in Postgres? I see a lot of hands up. Okay, how many people knew that Postgres had native built-in time travel query support? One. Okay, so it's true. There's this great paper about the history of the Postgres project by Joseph Hellerstein. And if you look in the section that talks about the storage engine, it talks about how Michael Stonebreaker wanted to simplify the model, right? That he felt that the transaction log approach was very complicated. So they wanted to have simplification. They wanted to unify. Data is log, log is data. And one of the upshots of this design, it also enables time travel queries. You can run queries as of some wall clock time and access versions of the data that were committed at that time. So this has literally been a feature of Postgres from the beginning. So why doesn't anybody in here use it? Why doesn't anybody in here even know it exists? It's because it's not in the product anymore. This is the official documentation from the Postgres website for version 6.3. This is the oldest version documented on the official Postgres website. You can see that there is an official time travel section in the table of contents. But if you read that text, it says it's no longer supported as of Postgres 6.2. And to give you a sense of how old this is, we look at this little note. This is dated January 12th, 1998. So this has been out of the product, or at least unsupported in the product, for almost 3 decades, which explains why nobody in here uses it or knows about it. Which is really a shame when you think about it, because it's a really, really useful feature. Now, I mentioned that I am a DevTools developer. That line about having implemented multiple time travel debugging systems in my career, that's not an exaggeration. That's straight up truth. So as you can imagine, my favorite on this list is the debugging. But there's a ton of other value around reporting and auditing and regulatory compliance that time travel becomes a really valuable tool. The Postgres community, much like nature, abhors a vacuum. So over the years, we've seen a variety of other implementations of this technology come to the light and be used in the industry. Several, lots. All of these have generally a shared design. Every app table has a corresponding history or audit table. And then you have some mechanism like a trigger or extension that runs when the app table is updated in order to modify the history table. And all of these generally similar designs share a set of significant issues. First off is data bloat. You're all familiar with what happens in Postgres if you turn off the vacuum. Same thing here. You're automatically keeping every record, every change in every table. That can bloat very quickly. So that's a lot of extraneous data in your production database. The second thing is it causes what's called write amplification. Every time you're doing a write to the main table, you're also writing to these history tables, which means that that's time that your database is not doing production work. So over time, these solutions have not really seen a large uptake in the industry. Now, I work for a company called DBoss. For those of you who don't know, it is the latest startup from Michael Stonebreaker, the original creator of Postgres. It started as a research project between his database group at MIT, where he's a professor, and a database group out of Stanford. Two of our founders are recent PhD grads from Stanford. In fact, one of them is my primary colleague on this project, and she did all of the original research and did all the transformation logic that we will see over the course of this talk. And they came up with this novel approach for how to do time travel querying. First, this isn't exactly brain surgery, but put it in a different database, right? Right off the bat, that solves 80, 90% of your problems, right? Because it doesn't really make as big a difference if you're bloating up your Providence database, is what we call it, a specific type of analysis database. We've obviously been doing this as an industry for decades, to pull data out of your production system and write it into a separate database for analysis. This is just another kind of analysis, time travel queries. How do we get the data out? We leverage logical replication, change data capture, log shipping, right? This is infrastructure that's built into Postgres and every other major relational database out there that allows you to pull data off of a production system in order to be able to create a hot standby. So that way, if your primary server dies, you can very quickly switch over to a secondary server with a minimal, if any, loss of information. That is got very little impact on the performance of your production machine. So we're able to pull the data off of the production NAP server with minimal impact, unlike what you see when you're trying to do all of this history tracking in the same database. Now, of course, if we just leverage that logical replication, we'd end up with an identical copy, which is not the goal. So we actually transform the data as we pull it off as part of the change data, as part of the logical replication process. We transform it into a model that's called multi-version, and we will see the details of that over the course of this talk. This adds essentially transaction snapshot information to each change record. That's how we track the information about when the changes occur. So now you end up with this database that has every table, every change of every record, but how do you interact with it, right? That's a very different structure. I mean, it's obviously a similar structure in terms of query and in terms of schema, but it's really a lot harder to work with. So we provide an additional time travel proxy. This provides what appears to be a normal Postgres database. This is wire protocol compatible. It's the reason I had to steal the book from Jeremy, was to read all about this stuff. In order to be able to provide what looks like a normal database, but a normal database with a couple of extra special commands, SQL commands that allow you to change the idea of now. And we will talk about all of this as we go through the talk. And we'll have a demo. In fact, you'll even get a demo of some cool stuff that isn't quite related to time travel debugging and isn't quite shipped yet. So let's first talk about the multi-version format. So similar to the model we talked about earlier, for every table in your production machine, on your production database, there is a corresponding history table in the Providence database. We're using the logical transaction ID as a logical timestamp. So every table ends up with two extra columns, a begin transaction ID and an end transaction ID. The begin tells you when this record was created. The end tells you when it was deleted. And we model updates as a delete followed by an insert. Each version of each record is only visible for transaction IDs between the begin and end transaction ID. Now, how many other people here have read the Postgres internals book or have some understanding of the internals of how Postgres's transaction management system work? Couple? This probably seems pretty familiar, right? This is essentially the way Postgres implements multi-version concurrency control. We're just taking that information that is implicit in a normal production Postgres database and surfacing it in the Providence database so that we can work with it. So let's see an example of this. This is one of our demo apps, the widget store. And in the production database, at any given time, this widget will have some inventory. So let's say for the sake of argument, we have 98. We look at the Providence table, we'll see the historical information. It started at 100. That was introduced in transaction 24818. And then in transaction 24824, we sold one. So the inventory went down one. And then in transaction 24826, we sold another one and it dropped. It was decremented again. You'll notice that the end transaction ID of the final record here is infinity. That is the sentinel value that we indicate to show that this is the current value of this record. We do this transformation as part of that extraction process that's using the logical replication. So let's talk a little bit about that process. This information is available. There's a binary format for it, but we use a very popular plugin called WoW to JSON, which allows us to extract this information in a JSON format. And here's an example of one of those kind of records. This is an insert. This shows you that this was the original insert of adding the premium quality widget to the database. It happened in this transaction. It's an insert. The schema is in the public namespace. The table is products. You see we have the information about the schema and the types of the records. All of this is just information. This is just normal stuff that Postgres does out of the box with the extension of making it JSON instead of a binary format. We then take this and stick it into an ETL-like pipeline, right? Extract, transform. I'm blanking on load. Thank you. Shouldn't that be save? Shouldn't be EL? Never mind. ETS is probably not the right thing. Anyway, so we add that transaction information. If we go back a slide for a second, you'll see that we have the information about the transaction ID that's caused this change. So we add that information to the table. These Providence records are append only. We never delete them out of the database. And the only time we ever change them is to change when we see a record gets changed or deleted, we have to update that end transaction ID field. That is the only modification that ever occurs in the Providence database. Changing existing data. We obviously insert all the time. So when we do an insert, we set the begin transaction ID to the value of, we set the begin transaction to the transaction ID that did the change, and we set the end to this infinity sentinel value. So here's an example when we originally created the widget in the database, set it to inventory 100, and we gave it a begin transaction ID of whatever that transaction was, and we used the sentinel value for end. Delete, we just modify that end value to match the transaction that actually did the delete. So in this example, we're just deleting that widget from the database. So we update its end ID transaction to that transaction value. And again, we model updates as an insert followed by a delete. So we take the same example. We started with 100. We had a begin transaction ID and a sentinel end transaction ID. Now we have two records, one for 100 and one for 99 widgets, with the begin, the end transaction ID of the original and the begin transaction ID of the update having the same value. And the sentinel value is now moved to the last one. Now, we talked a little bit about bloat and size. We can actually garbage collect this. At DBOS, we provide a Providence database for free, and we keep 3 days worth of information. If you get onto our pro tier, I think it's 30 days. And if you need longer than that, right, we have salespeople you can call. That's it for the sales part of this. And I was just using that as an example to talk about garbage collection. Don't run me out of the room, please. Anyway, you can bound the size of this by just deleting based on that end transaction ID. So if we have this information in the database, these are the transaction IDs, and we say, gee, we want to collect up to this point, we basically just go through and delete all the records where the end transaction ID is less than that value. So we can and still do vacuum the provenance database. But again, that's configurable. And because it doesn't impact the production database performance, that is a very much easier to control thing than works for your when you have to worry about vacuuming your production database. So now you have this data, but how do you interact with it? And that's where the time travel proxy comes in. Now, this is the part of the talk I like to talk about the most because it's the part that I built. As I mentioned, my very brilliant colleague, Chin, she designed all of the relational transformations we're going to see, but I got to write all the code. So the whole point of this feature is to provide a natural and familiar experience for accessing the database. I want to be able to just select data from the database, from the time travel database, the same way I interact with my production database, but with the added construct of I can travel in time. So this time travel proxy implements the Postgres wire protocol. So it looks just like a Postgres database, which means you can connect to it with your application code. You can connect to it with typical Postgres admin tools. We'll see a demo using pSQL, but you could also use like dbeaver or pgadmin or whatever other tools you want. We've actually lifted the Postgres query processor, the query parser, not the processor, not the whole processor, but just the parser, comes out of the Postgres code base. So we're using the exact same SQL parsing as the Postgres, as the main Postgres database does as well. Now, in addition to implementing the wire protocol, the time travel proxy keeps track of the current time. What is now for this specific connection? Each individual connection can have a different construct of now. Now, typically we deploy this time travel proxy to the developer's machine. So there's only usually one connection. The developer connects to the proxy then connects to the database, which is running in the cloud. But it's architected so that way over time, if we want to move this to the cloud and we want to be able to support multiple connections, we could be able to do all those kinds of things. And of course, if there's a concept of current time, we also have to have a way to modify the current time. So we've actually implemented a couple of custom commands that allow you to change what the concept of now is. You can specify the now directly, or you can specify the now as in terms of when this workflow, which is a DBOS transact construct, when this workflow started. And you can reset it back to current time if you want to. Then any query that you make against the proxy gets automatically transformed so that it would replicate what a query against the database at that point in time would have actually looked like. Similar to the way that the MVCC implementation inside of Postgres works, a record is visible if the transaction ID occurs between the before and end, at the beginning and end of a given record. So let's see this in progress. So we're going to use our widget table again. We're going to just select product and inventory from products. And when you first connect to the proxy, now is the current time. So when you say, hey, I want to do this query, it's going to look for the record that has no end transaction ID, right? Because the current transaction ID is going to be higher. Essentially, it's the Sentinel value. So it's going to look for the value that has the Sentinel value. So then you say, no, I want to change my timestamp. Now, you'll notice I put this 24825 in brackets. That's not the exact way that the syntax is done. The syntax is done with either you can specify it as an actual time and date, like in ISO, whatever format, I forget the name of the ISO format, or you can specify the workflow by identifier. And we'll see that in the demo at the end. But that's not important right now. What's really important is to realize that we're changing the value to whatever value you put into time travel, we map it to a transaction ID. So we're seeing the output here, right? Whatever you type in there, we will map it to a transaction value, and that's what we end up putting into for the query. So in this case, we're going to move now to 24825. So now when we execute that query, we're going to look for the value where begin is less than and end is greater than 24825. So when we do that query, instead of 98 for inventory, we get 99. If we change it to an even earlier value, and run the query again, now we see that we have 100. And if we move it even further back, and we execute the query, we get no results because no records were created in this table at that point in time. So again, this mirrors the internal MVCC implementation. How do we determine which transactions have committed? Well, it turns out Postgres has, you can get this information directly from Postgres using the PG current snapshot function. This gives you 3 pieces of information. The minimum transaction, every transaction ID less than this one has committed. Every transaction greater than this one has not committed. And then because you may have some transactions that have committed that are between those two values, you also get a list of values that are between min and max, but have not committed. So that way you have a sense as to which ones have and haven't committed. This then allows us to append to the query that you provide us 2 additional predicates to check the begin and the end. So we're going to check to make sure that begin is less than X max, end is greater than X max, and that the begin and end are not in the are or are not, depending on whether you're looking for the begin or end, in the list of transactions that have not committed. In English, we're going to select the values that were added and also select the ones that have not been deleted from the query. So we go back and we look at this original query with 24825, where we don't actually have an XIP list because it gets to be messy on the slide. We're going to take your original query, select from products, and add this where clause to it. So everything you've seen up to now is vanilla Postgres. All we're doing is taking the data directly out of Postgres via logical replication and putting it in the Providence database. But I've been lying to you. My name is actually Bill. No. This is actually not enough to do code level time travel debugging, right? If you want to be able to replay, it's very common to have multiple SQL statements inside of a transaction in your code, right? That's part of the point of having transactions, right? I want to atomically do these multiple sets of things. If I'm only doing one query, one update, I don't really need a transaction that's going to automatically be atomic. But if I need to be able to modify multiple things in the same at the same time, and then you have to happen atomically, of course, we need a transaction. And this becomes a challenge, right? We need to be able to read our own rights within the scope of a transaction. That's very common in code. WoW, working at that level, does not provide you enough granularity. Each transaction can have multiple statements. Each statement can change multiple records. Each record may be changed multiple times within the scope of a transaction. The WoW will only give you the end state at the end of the transaction. It will not give you that interim state information. So in order to be able to do time travel debugging, we actually have a slightly more complicated model than what I've been showing you. In addition to tracking the begin and end transaction, we also track individual steps within a transaction. Now, this is very specific to the DBOS Transact framework. So this will not work with just any kind of arbitrary code. The proxy transforms insert, update, and delete statements into select queries, right? When you do an insert, update, or delete, what happens? It tells you how many records were affected. So we want to make sure that when you run your code, of course, it's very common for people to run code that modifies the database. Go figure, those crazy users wanted to change the data. So we need to be able to execute those against Providence database, but instead of actually getting back the information, we need to get the query data. We need to get back typically, though there are obviously select statements that are combined with update statements as well. For normal, just straight insert, update, or delete, we need to get back the number of records that were changed. So we retrieve that information as part of the proxy. We keep track of which statement within a transaction made which change. So every time you execute a query inside the scope of a transaction, we have a monotonically increasing counter that we just update every time that there's a transaction modified. And this is that begin and end sequence information. That way we can keep track of which individual information within the scope of a transaction has modified the data. And then we use triggers to record how many records were changed per statement, and we emit that into the WOW log so that we can then pull that information into the Providence database. So this has been a lot of talking. I think we should see some demo code. If you'll give me a second here, I need to change the Google Meet so that we're looking at the right screen. Here we are. Present something else. Entire screen, just this screen. Okay. Well, maybe it was already changed when I stopped presenting. Okay. So.
Can you ask a quick question?
Yeah, please.
The transaction ID, I think in Postgres are 32-bit and they can cycle through. Do you store in yours as a big int instead, or do you deal with that?
I think we're running 64-bit IDs for our stuff. I have to talk to Chin about that. I'm not sure off the top of my head. So real quick, I just wanted to show you the app before we actually look at it running here. So this is the move this off screen here. So as you'll see here, this is the widget store. I was showing you pictures of it before. This is obviously designed to be like an e-commerce website, but it's got some extra information. Like part of the point of DBoss Transact is it's for building reliable and fault-tolerant applications. So I don't think most companies have a big crash your app as part of the demo, but we do that automatically. And then we have information about orders that are in process, so you can restock and all these kind of things. This is for running the whole demo. So I wanted to show you a quick look at what it looked like before we actually ran it. Now this is running in the cloud, and it has time travel debugging turned on. And so that's actually not on by default. So you have to enable that when you deploy your application on DBoss. There's also one other thing I do need to admit, and it's not about my name. It's the fact that I discovered yesterday that time travel debugging is broken in the TypeScript code base that I'm about to show you. So you cannot replicate this demo at home, but today. But hopefully next week or the week after, we ship every week, and we've missed this week. So I'm hopefully going to get this fixed for next week's release, and if not, it will be for the week after. So it was very impressive to discover this, yesterday afternoon and be like, oh, I probably need to get that working for the demo that I'm going to show, tomorrow. So this is the code that lives behind it. So if I click on this Buy Now button, I'm going to move this off the screen here. Click on this. It's going to bring me to, now this is clearly the same web app. The idea that we're trying to model here is when you buy something on an e-commerce website and it sends you off to PayPal or Stripe or something like that, right? You have to wait for some period of time for the call to come back, typically via a webhook. Setting, of course, the original demo for this actually used the developer version of Stripe, and getting that all set up is a pain in the butt. So we wrote our own simple kind of example here to demonstrate the same idea without having to set up a developer account on Stripe. So now I can either confirm or deny the payment. You'll notice, by the way, that the available stock has dropped to 7 because we reserve the inventory regardless of whether we know if the user is going to buy it or not. So if I hit confirm payment and it says, hey, it's paid, you'll see here that the order showed up here and it starts to dispatch, and that's going to do its stuff in the background. We don't really need to worry about that. If we go back and we do it again, except this time we say, you'll notice it's now dropped to 6. If I say deny, it'll pop back up to 7, and the order will show up as canceled. So now let's look at the actual code for that. So this is just TypeScript code. You'll see here that we're going to start by subtracting the inventory. This code is marked with a DBoss workflow. This is what makes it a long-running, reliable, fault-tolerant series of execution. It's going to subtract the inventory right away. If it doesn't have enough, it's going to crash out of the, it's going to alert the caller. And by setting this event, we have an entire eventing and messaging system built into DBoss. We're going to create an order in the database, and then we're going to set an event that says, hey, we're waiting. Here's the URL to get, for the information about this order. And we're then going to wait for a order to come back as either paid or failed. And then based on whether it's paid or failed, we're either going to mark the order as paid, which then kicks off the background process that we're not really going to talk about, or it's going to mark the order as errored and put the item back in inventory. We saw that in the application when I denied payment, it re-incremented the inventory. And then it'll set another event so that code running on the outside of DBOS can see that this workflow has completed. Now, you'll notice here that I have this button called marked as replay debug. So this is a new feature that's coming in next week in DBOS. That same information that you use for being able to have fault tolerance and reliability, you can also use for debugging. So if I click here, of course, I don't actually have this running locally. So let me log into DBOS Cloud real quick. This is actually the second demo I did today, and the second one and the first one, showing it off locally versus showing it off in the cloud was a part of the demo, and that was not the part of the demo today. So give me a second here. Let me just get logged in. Okay, so if I click on Cloud Replay, now if I go, actually, before I do that, let me just come here to this code. You'll notice that I have a breakpoint here in subtract inventory. So this is just going to run, query to automatically. I'm using DBOS supports a variety of different object relational mapping and query building engines. This one's using Connects, which is the one that I tend to like. So we're just gonna, reduce the inventory by 1 in the product inventory table. And this being a demo app, there's only one product that you can buy. So you'll notice here, as I said, I've got a breakpoint here in the workflow, and I have a breakpoint here in the transaction. You'll notice this code is marked as a transaction to indicate that I'm talking to my local Postgres database. You can also have what are called steps, which I don't know if there are any in this file. These are scheduled workflows, more transactions. You can also have steps, which are when you're going to call out to some external system. So like where is that one? I thought we had one in here. Maybe we don't. I guess this demo doesn't have a step. Everything we do is talking to the local database. So if I go and I say I want a cloud replay or replay debug, I'm going to pick the oldest one. You'll notice here, these are the two that I just ran, 704, 705 today. And then these are all ones I ran yesterday. So I'm going to run this one, just the earliest one in the system. So this is now going to launch DBOS in a special debug mode. You'll see here that I'm running here the DBOS debug command with the identifier for this specific transaction ID. This is just a random string that we generate in the application. And you'll see that we've broken on this point. And if I step, and I'm going to hit the step into, it's going to step into the actual code of the, it's going to step into DBOS code. I don't want to do that. I should have stepped over. But you'll notice that we did not break inside of subtract inventory. One of the things that DBOS does is when you re-execute a workflow, every individual step, it checks to see, whenever you execute a workflow, even the first time, it checks to see, have I already run this step? And if I have, just return the results. That way, if you crash and you come back up, you know what the list of workflows that we're running, you know which step of each workflows have already been done. You don't redo any work, which is really important for a lot of business scenarios. It's really important that these things happen once and only once. Don't charge the credit card twice. Don't ship it to the customer twice. You get the idea. So in this demo, because this is the replay debugger, this isn't using any of the Providence database information that we've been talking about today. We don't get access to the individual steps. So I can't step into these individual steps. All I can do is debug the actual workflow. Now I get the full debugging experience, right? So you can see here, I can see that this was order number 1, and I received the notification as this one was paid. And then I can step through this code and we can see that the logging information occurs out, et cetera, et cetera. If we run a different workflow, let's close this up. If we run the second to oldest one, which is one that I denied, and we come down to notification, we'll see that notification was failed, order ID was number 2, et cetera, et cetera. Okay. There's a variety of different durable workflow products on the market. Some of them call this time travel debugging. It's not real time travel debugging. They all support this kind of replay debugging. Okay, so now let's go through and instead, let's pick the time travel debug button. So again, if you install this is the new version of the extension that's coming out next week. If you install it, the time travel debug button will not be there. because, as I said, we're broken, but that'll be fixed in like another week or so. So if I click that, we're going to get the same basic experience of picking a workflow. So we're going to pick the oldest one again. Now you'll notice here that a new terminal has shown up. This is the DBOS debug proxy. So we've actually launched that debug proxy on your machine automatically. We download the latest version when you start up VS Code, and we launch it automatically when you do the time travel debugger. And this is just dropping off. We'll be able to see the different queries here. The queries against the DBOS schema are not transformed because of the way that all works. But so we'll actually be able to see here that as we walk through the code, we'll be able to see the transformations occur. So I'm going to step over subtract inventory, and you'll notice that it is in fact broken inside of the app. So now what's happening is, as part of running the time travel debugger, we've told the proxy what now is, right? Run this as of this specific workflow that that the user selected. In fact, if you look here, you'll see this command here, this -- proxy. That's the command to tell the proxy what transaction ID to use, right? So now we're going to pretend that this is the current point in time. So now I'm going to run this query to get the number of affected, to update the inventory, to update the inventory in the table. And we can see here that the number of affected rows was 1. So now let's actually look at the output in the proxy window for just a second. So we can see here, this was the original statement: updates products, select inventory, where product equals and inventory is greater than blah, blah, blah. And you can see that it was transformed into a select query. As I mentioned earlier, you can do insert, update, and delete queries. And if they're not ones that return data, we transform them into count queries, so that way we can return the number of records that would have been affected when you ran this insert at the time that the code, at the state of the database as it existed at the time this was actually run. And then we can walk through it. Now, okay, great. So now I can walk through this code of my transactions in addition to the code in my workflow. But what's really cool here is you can actually make changes, right? So now this is a copy of the code that's running in the cloud, but I can change that. So I'm going to now uncomment these 2 lines of code, which is going to actually get me what the actual inventory was, right? This query, this query here didn't actually tell me what the inventory was. It just reduced the value by 1 and told me whether it was successful or not. This one's going to tell me how many items are actually in there. Now, I do need to rebuild because this is TypeScript. The Python version does not need this, but the Python version doesn't have time travel. This has broken time travel debugging. The Python version has no time travel debugging yet. So that's why we need to do it that way. Now we're going to come back here. We're going to pick time travel debug again. We're going to pick the oldest one again. And it's spinning up. And again, I'm going to step over the code. Now this time, I can run this code, and it's going to run that query, and it's going to tell me, and I'm going to see back, I've basically selected the inventory, and I can see that it has 11 in the value as items in the database. If we actually go look in the actual database, of course, the data that's in the database isn't going to actually match that, right? We're going to see that there is 7 items in the database. So again, we're able to time travel to see what the state of the database was when we actually ran this code. And we're even running this, you'll notice we talked about the idea of like working within the transaction. We started with 12, but we've automatically modified it. So we actually are getting back the right number of value at this point in time. If I move this to be before, I would have 12. Now I have 11. And I can also then log that out to the debug console. You can see here that I've got remaining item inventory of 11. Please.
While you were at a historical point in time, can you start doing update statements that didn't originally happen?
You can do update statements, but remember we transform. So Did your question get, should I repeat the question?
Repeat the question.
Okay, so the question is this read-only or can you do inserts? You cannot, in fact, change the past, right? It's not real-time travel. So no, you can't do insert updates or deletes. Inserts, updates, and deletes are automatically transformed into select statements anyway. So you could add a query here that says, if I had inserted a record here, what would I have gotten back? But you won't actually change the past. You don't actually have, we don't give you write access to the Providence database. So, anyway, so that is time travel debugging. So now, since we have this terminal open, right? We still have the terminal open. I can shut this down now, right? But I could also launch it directly if I wanted to. So I'm going to come over here to applications. You'll notice that there's this little button of the debugger, and it says launch the time travel to proxy. If I try to launch one that isn't enabled, it'll just pop up and say, hey, that's not enabled. For performance reasons, you can't really detect that ahead of time. But for widget store, I can launch it manually. So again, now I haven't done anything different than what I did when I hit the debugger the first time. When I hit the debugger, it launched the proxy for me automatically. Now I'm launching it manually. And the reason I'm doing that is so that I can come over here and go to the console and log in with PSQL. Now, you'll notice here that I'm logging into localhost. I mentioned the proxy is running locally, and we're running on port 2345, the inverse of the normal Postgres port, right? You can run this. That's all configurable. This is just the default. You'll also notice there's no security, right? Because while we do support this idea of multiple connections, we haven't really done the security work, which is why we're deploying it to the developer's machine. We assume the developer already has access. We have to go get the credentials. We pass the credentials for your cloud database, your cloud Providence database. We pass it to the proxy when we launch it. So all of that security stuff is happening as part of the extension. So we don't have additional security in the proxy today. That's something we could add down the road if that was an important thing. So if I say select star from products, we can see here that the current inventory is 7, which we saw earlier. We are querying the Providence database now, by the way, not the production database, but you can see that the values are the same. So now if I say, and I'm going to remember I'm just going to copy this from here because I'm lazy. I'm going to select, this is the list of all the workflows that were in the system. So if I pick one of these, was this the oldest one? Hold on 1 second here. I thought that was, it's JXZ. Okay, so it's this first one. So if I take this one and I say dboss workflow and give it that value. So you can type out workflow, but I've just typed in WF as the short version. There's basically 3 different custom commands. Go to the time travel to this workflow, time travel to this timestamp, or time travel back to now. So I can reset that value back. So I'm going to travel to this timestamp, and I'm going to actually remember the semicolon. And now I'm going to execute that same query I did before for select star from products, and you'll see that there are 12. So when we started the query for this first transaction, this first workflow, there were 12 items in the inventory. Now you'll notice that I didn't have to reload. This was instant. I didn't have to do a whole bunch of, like, normally a lot of this kind of like, I want to travel to this snapshot requires reloading the entire database, which is a very time consuming thing. Because of the fact we're keeping all of the data in the database, for as long as you're willing to pay us to do it, we can do the time travel operations instantaneously. And then I can go back to now, dboss, snapshot, reset. Actually should just be dboss reset. That's a slightly annoying command. And we're now back to 7. So again, we've now seen replay debugging. I didn't show you local replay debugging because I don't have a local database set up right this second for this app. You've seen cloud replay debugging, a new feature that's coming next week. And you've seen time travel debugging both in code and as in interactively using PSQL. So let's go back to the presentation for just a second. And I'll bet you where's my meet window? There it is. Change this back to the correct presentation window. Okay, so with that is the end of my talk. You can get, of course, I will make these slides available to Jeremy so you can get these. You don't have to write this stuff all down, or you can scan the QR code. This is our interactive time travel documentation, which is currently, the documentation is there, but the code is broken. So don't go do this right this second. And there's a blog post about the time travel, goes into a little bit more of a history of it. So in summary, we're doing time travel by storing the history data in a separate database, which eliminates a lot of the problems with existing previous time travel debugging solutions on Postgres. We use the existing infrastructure for logical replication to take that data out of the production database and transform it into the multi-version format that allows us to do the time travel query. We have this time travel proxy that provides a natural and familiar query interface on top of the database so that you can query it like you would query your production database, but still travel backwards and forwards in time. Well, not forwards from now, obviously. Can't predict the future. AI might be able to do that, but I'm not an AI guy. And then finally, we are tracking inter-transaction statements in order to enable full time travel debugging, including reading your own writes. My name is Harry Pierson. Thank you so much for coming. This is my email address and my handle on the vast majority of social media networks. We have a Discord that you can join. I'm on Blue Sky. I'm not on Twitter anymore, thank God. Instagram, TikTok, whatever. You can usually find me at DevHawk. So I'm a very big believer in that the best way to build great apps and great products is to talk to great customers. So please, please, please feel free, pick my brain while I'm here. And feel free to reach out to me. And if you lose this information, Jeremy knows how to get a hold of me too. Thank you very much.
I have questions. I don't know about other people.
Feel free.
I have some really basic questions.
Hit me.
I don't think so. So DBOS, is it not just a cloud database? It seems like a whole.
It is not a cloud database. We use Postgres. In fact, we use RDS, right? We run in AWS. So we just need vanilla Postgres. Theoretically, it could work. We think it will work with any Postgres wire compatible protocol like Cockroach or Yugabyte, but we don't test that. So.
Well, so, I mean, to that, I actually kind of have a similar question. From what I've read on the internet, I haven't read much. I think you guys are a durable workflow engine. Is that the right?
That is a great way of putting it. Durable workflow engine.
So that sounds like I've heard of something called Temporal, which I think is also a workflow engine, right? Mm-hmm. So I don't know if that means anything to you. I don't know much about this category of stuff. Do you want to just give the 1,000-foot overview of what?
Sure.
What
the 1,000-foot overview of this is that in typical app development, your baseline happy path is usually pretty short, right? If you look at what it takes to write code, if we look at the code, let me shut the demo down here and just go back to the code just for a second.
You have to switch the screen again.
Do I have to switch again, or did it automatically happen because
I don't see what's on the.
No, it doesn't look like it.
No, I don't see that.
Do you see the code now?
Not yet.
Okay, I will fix it then.
All this back and forth. Sorry, guys.
No worries. Hey man, I'll get a recording of
There
this.
you
That
go.
makes me very happy. So if we look at just this for a second, right? If we look at this is the logic behind the buy button of the widget store. And there's some try catch hey, it's possible that the inventory will be 0, in which case I can't update the inventory, I can't proceed forward. And well, I'm going to get the payment could fail or not fail. But there's not a lot of other error handling in this code, right? Right? I mean, this is the happy path. This is what I want to write. I don't want to write what happens if CrowdStrike pushes out an update and my entire server farm goes to shit and I have to restart everything. Which is a thing that happens, right? I know nobody in here would ever have any buggy code, right? But hardware fails and software fails. Operating systems fail. So even if you don't do anything wrong, there's still lots of other things that can possibly go wrong. So the way that you solve that is you either write all of that recovery logic yourself, or you use a durable workflow execution engine. One of our earliest customers had been trying to do, they are a company called TMG. They integrate, they have a solution that integrates Shopify with SAP. And they have this great quote. We got farther in 2 days using DBoss than we got in 2 months using AWS. Because they don't have to write all that error handling code because it all lives there behind that little @dboss.workflow. We automatically record the workflow started. Every workflow has a unique identifier. If you don't give us one, we will generate one for you automatically. That workflow, you can't do once and only once. Like computers can't guarantee once and only once. But you can get really, really, really close to it if you are item potent. And that's what we do by having a unique identifier for every workflow execution. We know which workflows we're running, we know which workflows have completed, and then on every single one of these steps, when you call set event, when you call create order, when you call subtract inventory, under the hood, we check to see has this step X been executed, and if it has, we just return its value, which is why we can walk through it in the debugger even though I did this yesterday.
How is this similar and different from function as a service?
Function as a service does not have that transactional integration. You could, and that's what I think, I don't want to speak for TNP, but I think that's what they were trying to do. Function as a service is just raw function, right? It's just like any kind of other, it's just a bunch of, pick your language, in this case TypeScript. It's just a bunch of TypeScript code. It doesn't do anything else for you other than spin up when the request comes in and shut down when the request shuts off. It also, by the way, double charges you, right? Because if you think about something like the subtract inventory query, right? Where are you spending most of your time? Waiting for this query, right? So this request is going to come in, and you're going to then, if this is obviously a step of a larger workflow, so you're not exposing this directly to the internet as a function as a service, but you could. So if you were going to do that, you do this little bit of work to construct a SQL query, and then you will pass it off to the database where all of the real work will be done, and then you will, remember we commented these 2 lines out, these 2 lines were commented out, we'll do a very brief check to make sure that it was successful. So the amount of code, amount of execution in the middle tier, in your app tier, is almost none. 98, 99% of the work is happening on the database tier. But Amazon is more than happy to charge you wall clock time while this executes. So while your code is running in the function as a service, doing nothing but waiting for the database, you're getting charged for that, and of course you're getting charged for execution time on the database. Quick note, DBoss does not in fact charge clock time for execution on in this kind of a scenario. We only charge you for the database time. There is more similarity, not so much with function as a service, but I forget whose is whose. Like I remember Amazon has Lambda and Azure has functions, and they're vaguely similar. And then there's durable functions and step functions, but I forget which brand goes with which company. That's more along the lines because it's more of a workflow kind of thing, but it doesn't have the automatic recovery that DBoss has. Right? When you hit that crash button in the demo, it'll automatically, we will detect that the crash has occurred, which is fairly common in cloud services, but then we'll automatically respin up all of the workflows that were in process. We will automatically, for each workflow, because we're recording the results at every step, we automatically then start executing each one of them, and each step that's already occurred, we just skip over. We don't do that work a second time. That's how we make these workflows execute once and only once, even in a unreliable, non-fault tolerant environment of the modern internet.
What would like a case be where this is all overkill? Like even maybe function as a service would be overkill, and you should just do something basic and simple and not.
Well, I mean, so first off, it's transactional. Like if you're not doing transactions, you're not doing database stuff. Well, it's funny I would say that because it turns out we have a bunch of customers that actually don't do a lot of local transaction. We have a bunch of demos now, we're seeing some interesting uptick, for example, in the AI space because you guys have all seen the news about the guy that tricked the chatbot into selling him a $100,000 car for $20, right? So how do you avoid that? Put a human in the loop. How do you put a human in the loop? You have to start contacting humans, which now means you have this workflow that was in process, trying to buy a car, and now you have to stop cold and go talk to a human. And that's going to take an essentially infinite amount of time from the computer's perspective, right? I mean, that's going to take forever. How do I keep track of where I was in this process? Durable computing. We actually have a really cool demo, which I'm not prepared to demo right here, of a reliable AI agent for doing refunds, right? So if you say, hey, I want a refund on my earphones that were $50, it says, yeah, no problem, I'll give you the refund for that. I'm not gonna go bother a human being. I want a refund on my $1,200 computer, I'm gonna go talk to a human being. And it will dutifully send off an email, and I get a bunch of these in my inbox because it's a demo app. And you know, somebody gets either yes or no, and then it will go back and update the database. So the workflow of the AI kicked off, the AI kicked off this long-running workflow, which involves a human in the process. So those are a lot of those kinds of scenarios where you may not even have a local database that you care about. We do in that demo because we are keeping track of the list of products that you can ask for a refund on. But like to go back to the example of TMG, they're trying to integrate data from this system and that system. Well, that's 2 steps, and they're not transactional, right? I can't open up a transaction and talk to Shopify and talk to SAP, right? They're not sharing a transaction. That the whole 2-phase transaction across systems, like nobody does that. So how do I reliably take data out of system A and put it into system B? Well, I have to keep track of what times I was trying to take data out of system A and put it into system B. I got the data out of system A and then I crashed. I didn't get a chance to put it into system B.
These all sound sort of like business processes.
It's very business process.
As opposed to like, if I'm have an API that's just like get stat or get inventory, right?
Oh, yeah.
My get inventory API, that could just make a quick database call to a single query, return it literally in like milliseconds every time. I might not need a whole full-blown workflow.
You would not. So first off, it's a query, right? Second of all, it's an individual operation, so it's automatically atomic.
Right.
It's as soon as you get, like, look, there's the old joke, there's only 3 numbers that matter in computer science, 0, 1, and more than 1. As soon as you get to more than 1, you need some kind of durable computing engine in order to make it reliable.
I think that's the distinction I was looking for.
Yeah.
Of like the workflow stuff makes sense as you're getting out to like processes with a bunch of steps in them, as opposed to just like run, get this one little query.
Oh yeah, no, you would never need something like this to just get
stats, get inventory level.
And even get multiple things, because you're not really making changes to it. It's probably not that big a deal to just re-execute the query. Like even if you wanted to say, like, if you wanted to make sure you had a consistent view, you could begin a transaction, do query A, do query B, do query C. These are select queries. Yeah. And then commit or roll back the transaction. It doesn't really matter because you haven't made any changes to it. So that would still give you a consistent view within the scope of a transaction. But you're not really then in turn making a second transaction, right? So you're not trying to do 2 different blocks of work that you can't put into a single transaction. If you can put it all in a single transaction, durable workflows are overkill. And if you're like, I'm going to read and then write, if that's the situation every single time, and it doesn't matter like what you're reading, like, and not that it doesn't matter if it's changed. Like I don't have to keep track of what I read this one time, right? If that's the case, then the read is automatically going to be idempotent because you can read as many times as you want. The data might change, but like reading, if you read the data multiple times, it's not going to affect the system. It's the writes, it's the changes that you have to make idempotent. And as soon as you get to multiple changes that have to occur atomically, but you can't enclose them inside of a single transaction because they're in separate systems, or like in the example we see here, we're going to subtract inventory, we're going to call the user out, to send the user out to pay, and then we're going to do something different based on whether or not they paid or didn't pay. Yeah, obviously I can't put all that in a transaction. Even if I knew they were going to pay, which you don't know, you're still not going to hold open a transaction between I'm going to update the inventory and I'm going to wait the interminable long amount of time it takes for the user to come back from the payment system.
That was very helpful to me.
Yeah, no problem. And I told you I wanted to talk to you about Geico because I imagine Geico has 1 or 2 or more step processes inside their company.
1 or 2.
1 or 2.
Ben, did that kind of like, was that clarifying for you?
Well, yeah, I think where I came to this talk when it started was that there was an audit log somewhere, and I quickly realized that DBOS is far more than just an audit log somewhere.
An auto log?
An audit log?
Oh yeah, no, it's more than an auto log.
Yeah,
Well,
yeah.
the audit database, the Providence database is a piece of it, but obviously the entire it is a lot more than that.
Yeah. So it makes a lot more sense now.
Cool. Yeah, I did a little salesy thing in the middle of it, but generally speaking, they don't like you to come to these events or to pass or whatever. And let me tell you about the great new DBOS. Yeah, no, that's uncool. So I don't do that. I'm happy to talk about it if you want to ask questions, but I'm not gonna
Well, I have
push
another
the
question
sale.
that's more technical. So you talked about lifting the Postgres query parsing code.
Yep.
Which, so I'm familiar with a bunch of projects doing that. Like this is not, that's really an interesting thing. And like from, I want to say like, I think PG Cat might be doing it actually, or maybe Odyssey. Like one of the PG Pool probably does, like any of these pooling type
PG
proxy
Analyze?
things. Yeah, PG Analyze.
That's what we're using. We're using PG Analyze. So
Well, and then, I was going to ask, like, because don't they have like a separate GitHub repo
Yeah.
where they put the parser there and they're kind of,
Yep.
so they're keeping it up to date with. So my next question, follow on to this, is which major version of Postgres
16.
did you start with? 16.
16, and I haven't worked because we're a small
Yeah.
team, and like
So
right
I-
now, let's see, between updating to Postgres 17 and fixing the fact that time travel is completely broken right now, one of those is a higher priority.
So
So
if I try to query syntax that was brand new in 17,
It
the
would-
proxy wouldn't take it yet.
it
right?
would not.
Yeah.
And you would find a bug, and I would fix it. And,
Okay.
yeah. So just a little bit of background since you asked about it. So our entire backend is built in Go. And our original implementation, I lifted the parser from Cockroach because Cockroach actually, somebody else has already taken the Cockroach parser and put it off in a separate component. So since we were writing in Go, since it was all Go, like this will be easy, and I went ahead and did it. The problem is that Cockroach is PostgreSQL compatible, but their parser will do subtle things during parsing because Cockroach works slightly differently. For example, current user is not a variable, it's a function in Cockroach. So if you say, I want current user as a variable, the parser will say, he said he wants current user, but that's a function, so I'm going to turn that into a function. Well, what we're doing is we're parsing the code, transforming it, and then serializing it back out to SQL to send to a real Postgres, non-Cockroach database. So that did not work. And in fact, we had to change it in order to, the things like the pSQL worked fine, but like tools like PG admin and dbeaver, they do all kinds of weird queries in order to populate the UI. And I don't mean weird as in, I mean, they're not the kinds of things that app developers typically do, right? And so they're the kinds that and so as soon as we started trying to run, PG admin against the proxy, it barfed all over itself.
Yeah.
So, and once we got up to like you don't have create extension in Cockroach. So we knew this one right away because we had one of our demo apps had create extension. I don't remember what the extension was. So I wrote a little, in the parser, I'm like, look for create extension. If it's that, then just skip it. And it's return like, yeah, we did it, but we didn't actually do anything. Don't pass it on to anything like that. Because the parser didn't know how to handle create extension. That's not a supported feature of Cockroach. So, but once we got up to like 3, and then we ran into the current user one, and there was a couple of others I've forgotten, but like once we got up to 3 or 4, it's like, okay, this is done. Now, the problem, of course, is that, and I don't mean this is a problem, it's just we're written in Go, and Postgres, of course, is written in C. There's a really cool library that the guys who do PG Analyze have automatically wrapped. They've already done the work to extract the C code and wrap it in Go. It is it's not particularly friendly from a developer perspective. It's not in a public repo, but I wrote the world's ugliest switch statement because I had to write a node walker, and there are 200 and so odd different. Part of the reason it hasn't been updated to 17 is because I'm going to have to go through 200 and some odd nodes. I actually want to write code that will generate that switch statement, from the because it's where they use. And why PG Analyze did this, I don't know. They use protobuf to communicate between the Go code and the C code. So it makes debugging really a pain in the ass, but it does actually work. So And I didn't have to do it myself. So I had to write this really ugly switch statement that, Copilot helped me a little bit, but, anybody who thinks that Copilot, GitHub
Throw
Copilot.
off between Go code and C code. I
Yeah.
don't even know what they're doing, but that just sounds crazy.
Yeah, let's just say if I was doing it from scratch, I would not have done it that way. But here's the really funny part. When we were originally writing the code, the original code was all Go. And we, of course, shipped this for Windows, Mac, and Linux. And we ship it for x86 and for ARM.
Yeah.
So, all Go is really nice for cross-compiling, all great. Yeah, the Postgres C code, not so much. No. And so we were able to, the GitHub might have changed since then, but GitHub did not have a ARM compiler Windows action runner. So you can compile it, it's relatively straightforward to compile, it's just a lot harder to cross-compile. So for Linux and for Mac, we just, we spin up an x80 or x64 runner and an ARM runner. On Windows, we can spin up the x64 runner, but there was no ARM runner. So I'm actually using Zig to compile the C code from the Postgres to target, running it on Windows, targeting ARM. Running on Windows 64, x64, targeting ARM.
What is Zig?
Zig is a native programming language, so think of it like where Rust is trying to be a better C++, Zig is trying to be a better C. And it's a language that I am very enamored with and I think is very, very cool. They just shipped their latest 0.14 like 2 days ago. And I've been trying, but one of the things that, like Go and like Rust, it has a very, very robust cross-compiling infrastructure. And so
It can compile C code.
it can compile, yes, it has I think it's drop-in compatible for Clang for both C, C++, and maybe even Objective-C. Hey man, anytime I get to talk about Zig is a happy day. It's probably org.
So now I'm glad I asked. That was a really interesting tangent off of the parser code.
So,
General purpose.
I have one question. So how does that happen when we have a single transaction updating multiple tables? When you switch to a particular transaction ID, is that every other table updated to that state? Because you are constantly consuming the events, right?
the logical replication events?
Yeah, so it can happen that one event might not have come in the same transaction. I don't know, I'm just thinking of the failure situations.
That's not.
So
I mean, are you talking about the failure situations in the original database, or are you talking about replication failures?
replication failures.
Well, I mean, obviously, I built the time travel proxy. I did not build the export. My very, very brilliant teammate Jim did. So I don't know the specifics of how we are achieving reliability in the extraction process. As you might imagine, the fact that logical replication is used to build hot standbys means it's got a bunch of infrastructure in place to ensure that if something crashes in midst of doing the replication, you can recover from it. I am not familiar with the specifics of that. If you want to send me an email or hop on our Discord, I'd be more than happy to connect you with Kim. She'd be able to answer. She'd probably be able to answer the question you had about the vacuum rollover question that you had too.
So if everything works fine, then all the table will switch back to that state if we use that transaction ID, right?
Well, we're not switching anything, right?
I mean, not literally, but what we view from.
Right. So if you'll notice here, this is dbeaver, if you will, integrated into Visual Studio Code. You'll notice here that there's 3 databases on this is my cloud, my DBoss cloud database server. I've got one application in the toolbox that has the system database and the application database. We keep all of the DBoss information is stored in a separate system database, except for data related to transactions, because do all of the work within the scope of the transaction output table has to be in the same database as your app data. But you'll notice for widget store, we have the name app, the main app, the system, and the provenance table. So if we look at like widget store, we'll see here's products, and products has product ID, product description, inventory, price. And we can see there that there's one item. Now if we go and we look at the provenance database, and this is co-located, it doesn't have to be, it just is, for this demo app. You can see here that these are all of the changes that we made, and we can see here, there's that begin and end transaction and sequence ID number for all of those changes, and so we can see here all the changes, oh, we started at 12, we went to 11, we went to 10, we went back to 11. This is the, I placed an order, I confirmed it, I placed an order, and I denied it. That's why it keeps changing. So we can sort of see that entire history has changed all the way through. So all this data is available for you to see. It's not like we're keeping any of it hidden. And it's just being stored in a normal Postgres database. I've thought about the possibility of actually pulling it out into a non-Postgres data store, but again, small team.
Real quick. I want to see, is it the XID columns in here?
The which?
Is it the, what are your, okay, it is begin XID
Right.
and XID. So you can't see timestamps without doing some kind of translation, can you?
Yeah, and we have that. So if we look at the actual, if we look, now in the provenance database, we've put all the system tables. So if we look at the workflow status table, so these are all of the workflows that have executed, and you can see there's a lot of them because we have a scheduled workflow that happens in the background. Let me just filter this by payment workflow. Yeah. So if we look here at this is the information. As I said, we basically, when you start a workflow, we write down that it's going. So that way, if you crash, we have to start over again. We can see, here are all the ones that were in process. And so if we scroll over here, you'll notice that there's the workflow ID, and there's a timestamp, and there's the transaction information is in here somewhere.
So a workflow is a collection of transactions.
A workflow is a collection of steps, of which some of those steps might be local database transactions. They may not be. Like if you're talking to PayPal, that's not a database transaction. PayPal's not giving you access to their database. It must be, it's been a while since I've worked on this. The timestamp, the transaction information must be in a different.
It's in there somewhere. But in the
yeah, it's around
workflows,
somewhere.
there is one of these tables that is going to have information about that call out to PayPal, but that's just because sort of the DBOS workflow engine has to keep track of that.
Exactly. There's another, you mentioned Temporal, there's another company called Restate. They have, the thing that's really cute about Restate's implementation is that it's a standalone executable. Like it's one executable, everything's compiled into one executable. And they have all their information, all of their durable log information is being stored to a file, which is really cool, right? Because it's really simple to deploy, but it's really hard to query. This is really easy to query, right? And so we just store that information in Postgres, right? What's the best place to put this stuff? Postgres. As you can imagine, so as I mentioned earlier, Stonebreaker is one of our founders, and so you can imagine we're using Postgres, but we're also very heavily committed to everything just belongs in the database. There's this. You guys are Mythbusters fans? Right? So there's a great quote that, the difference between science and fucking around is writing stuff down. And so my joke is that the difference between durable computing and doing it wrong is writing stuff down in the database. So we write stuff down in the database.
What is the largest provenance database that you're aware of?
I don't know off the top of my head. I don't work on the cloud side.
Terabytes, you think?
No, I'm sure not. We're brand new, right? We've only been shipping this for a year. I'm 99% sure that we do not have any customers that are at that size and scope yet.
They've only had a year to accumulate workflows.
Yeah. Well, and as you can imagine, we shipped V1 of the cloud. We didn't have customers on day one, right? That was a year ago in March. In fact, like a year ago next week, if I remember, it was like the 13th or 14th or something.
Are you concerned though, like about scale on the provenance side?
No, because it's mostly static, right? You can partition that as forever.
Yeah. You're right, it is theoretically possible we will outgrow it at some point, but we can partition. So first off, we don't keep things forever, right? So we give you, as I said, I did all this yesterday because I think I've got a free account. I mean, I'm sure I could get a pro account. I know the owners. But I'm one of them. But I don't have it configured right now. In fact, we were doing traction. We were looking at customer lists the other day, and I noticed that one of the customers who was listed as one of the other engineers. I'm like, I think that's a typo. I'm pretty sure Max isn't paying for that. But it'll clear this out after 3 days. If I came back and didn't touch anything and I did this demo in another week, this would be empty. So I don't, we're still working. We don't have that many customers yet. We don't have that many customers yet that are using the time travel debugging. So I have no idea about the scale.
And for people who come in who are like, I just need 30 days of history, that's fine.
Yeah.
It's just going to be like that one person who's like, I must keep it forever.
Yeah. Well, this is the reason that I would like to hold on to that Postgres internals book for a while, because at some point I would like to think about, like, there's no reason why we have to use Postgres for this on the back end, right? It's an analysis database. It has to act like Postgres, so it has to query, it has to handle queries. As I said, even just switching from Postgres to Cockroach as a query parser, not even a processor, just a parser, broke things. So, we have to use a lot of the core infrastructure of Postgres, but like.
Have you seen all these people doing, all these people doing DuckDB embedded inside of Postgres now?
I haven't seen it, but I've heard a little bit about it. There's also OrioleDB, which is S3 on the back end for Postgres. So it's Postgres with an external.
I didn't think Oriole was S3 on the back end. I thought that's what DuckDB was.
I thought that's what Oriole was. I built DevTools, dude.
I think Oriole was the undo stuff.
I thought maybe I'm wrong.
I also got.
It's been possible.
Oriole got bought by who?
Don't tell my wife I said that I could be
We
wrong.
just did the demo. It's something we played around with in December.
Was it,
That's
it had a green logo? That's
Yes.
my memory.
Tip of my tongue.
It had a green,
What's that?
They already sold out, they just started to.
Yeah,
Yeah,
Super
gave
Base.
out the shirts.
No, was it
Super
Super Base?
base, yeah.
Yeah.
Super base.
I think Super Base bought Oriole. Yeah, see Super Base right there. Yeah, no.
Oh yeah, well, and we have super base integration.
This is undo. I think this is undo. This is different than. I think you're thinking of DuckDB. Yes, that's why I said DuckDB, because it's S3 on the back end, which could potentially.
Yeah.
I mean, it's column store. They can do. I want to say they. There's Iceberg.
I've done like a very small amount of thinking about, boy, it would be really nice to do this, but I've done almost no actual research on this. See earlier comment of small team.
Well, so
Right.
I want to.
We could feed the entire team with all that pizza for like 3
There's
days.
2 or 3 different people
Well,
that have
not
done it.
that.
Crunchy's making a bunch of noise about their solution. There was another one, maybe Parade. I can't remember who it was.
Yeah.
But there's a few people, and the advantage is because they're embedding it. So DuckDB is it's very similar SQL syntax, but these folks are embedding it straight into Postgres, so
Okay.
it might give you the stuff that you need.
I will take a look at that. I appreciate that. I would love, because again, I mean, as I said, right now, you'll notice like part of the value is, hey, we're going to run it on a different server, but right now, we're running the Providence database on the same server as your production database. That's obviously, something that's going to have to change over time, right? You can't really scale that. But that's fine at the scope and size we are right now.
That's
But
how you save money on RDS there.
yeah. Well, it's the kind of thing that we can, that's something we can easily, like, the same way that the debug proxy, we haven't done the authentication work to be able to run it in the cloud, but it's designed to be able to support multi-connection, even though there's usually only ever one connection to it. Same thing with this, right? You're not going to, at the scale we're at now, running it all on the same server is probably not that big a deal, but we have to. It's just a question of pointing to that database, not this database. That's a relative, I mean, any kind of change is, weeks worth of testing kind of thing, but it's not like a dramatic re-architecture of the platform to say, oh, now we need to put it in a database on another server, versus the other implementations of time travel, which is doing it all within the same database. You can't easily then move that to, and now I want to put it in a different database. That's a radical different change. Moving into a database on a different server is easy. Relatively easy. Nothing's easy.
So in MySQL, they have the replaceable database engine. To my understanding, Postgres is trying to do the same thing too, and OrioleDB was created kind of ahead of the full support of the replaceable database engine. Do you know anything? Is Postgres officially going to make a replaceable database engine so you can actually?
Probably what you're thinking of is, there was an EDB it's related to this. There was, because a lot of it ties into like trying to do like an undo model instead of doing vacuum, because vacuum is like sort of the thing. It works really well, but it is like,
It has trade-offs.
yeah, it has trade-offs. I don't know. It's
So what you're talking about, you're a more
Yeah.
slice of pizza.
So there was, what was it? ZHeap, that's what it was called. There was a project called ZHeap that I think some
It's still going, or is it dead?
I haven't heard a lot about it, so I don't know if it's being actively developed. It might have, like, there might not be anybody, or it might just be like one, who knows. I don't think it's moving real fast right now. But part of ZHeap, they did go into like Postgres, I think, and they improved the like the interface underneath.
I know Oracle did that too.
Underneath the heap to like support the idea of being able to plug sort of a different heap implementation underneath instead of the standard heap.
Because for example, then you can switch to in-memory database,
Yeah.
or what Harris was showing, we could in theory have back this
But
time.
the other thing is that, and this is kind of an interesting thing in general. So like, this was kind of what tied in my question about the major version, because like there's so many people who fork Postgres or like build products sort of based on a chunk of the code, and there's just 100 different things from like Aurora to Neon to timescale to Yugabyte, and like people just have all kinds of different creative ideas. This is one of the cool things about Postgres because of the license that encourages this. That like you can have any kind of crazy idea, you can take just the parser code and try to do something with that. And like the
I use that. It's good.
the thing that like
That's what
always
we
gets
use.
everybody is like the major version upgrades. So it's like you can fork Postgres easy, but keeping up is hard.
Yeah.
Right. And so but one of the things is like once you get like a bunch of people doing something, then I think there can, if it's just like one person doing something, then like, and then you go to like the core community and you're like, it'd be great if you kind of formalize this interface because that would simplify designing a product against those set of functions or that interface, and like there'd be less breakage every time you move forward with the major version. Like if you're just kind of Joe developer wherever, like they're probably not going to go out of their way. But once you get like a group of people who are really like bringing momentum back to the core project, then there's so this is where when you have a bunch of forks around storage stuff, I don't know, maybe there might be a point where there's more kind of reception in the community, maybe to sort of being, we'll see.
I haven't looked at
Not
Oracle.
just being awful as far as major version upgrades breaking everything.
Oh, well, sure. I mean, that's why. Forks are hard, right? Unless you have someone like
Forks and merges.
all of Amazon
Yeah.
standing behind like their
Well,
core
it's,
thing, right?
I
Like,
mean,
that's- they'll beat
the
that.
forks are fine if you want to be Redshift, right? Where you're just kind of like, and like you really have to do what Redshift did, and like you can't, you're not a fork. Like you don't talk about it. You don't even mention Postgres really officially. I mean, like it's okay that people know you're not hiding it, but you're advertising yourself like we are our own product. Like don't come to us and ask us to support Postgres 18 syntax. Tell us what features you want. We build our own product roadmap now. We do our own thing. If you've decided that as a priority you're going to fork, but you also want to advertise compatibility, like we're Postgres compatible, what comes along with that is like Postgres comes out with new major versions every year. So
Yeah,
like
that's how it works.
if you're going to do that, then your customers are going to come to you just expect it. They're going to ask. They're going to be like, so Postgres 18 just came out. It's got this really cool thing. Do you support it? And you're going to have to come up with some kind of answer. Whether it's cherry picking, whether it's merging, and all of these things can be painful.
But I think the community supports us with the challenge, right? Like you look at the history log of Postgres and they're like, the things that people have asked for and then just got slammed down over the years until what? Who would ever want that? And then eventually now it's a good feature, but it takes a while.
Yeah.
I was pretty sure, by the way, I hadn't actually realized that Oriole had been bought by Supabase. But I'm on the dev tool side, right? So But I'm 99% sure that they had like for their pluggable storage engine S3 backend to Postgres, they had, and we have a series of patches that you have to run our version of Postgres until those get accepted upstream.
Yes. Yes, I think so. Yep. Well, there's a couple like that.
I'm sure there are. I just know that one.
There's a set of patches that I think that gives you 64-bit XIDs floating around from maybe Cybertech or something. I don't know. Somebody's got one. There's a couple of. Another one is the one that does SQL Server compatibility. What's that? Babelfish. So Babelfish is really cool. But you have to apply a couple of patches on Postgres, but then it plugs in as an extension, and it like speaks the T-SQL wire protocol. But like what's really interesting is it like deeply integrates. Like it's not translating the SQL to Postgres. It actually has its own parser.
Nice.
Like it parses the SQL directly into like the native Postgres internal data structures and then drops them straight into the executor.
Nice.
It's really cool. But that's again, and that's I want to say I think it's Apache. It's open source out on GitHub, but it is a set of patches you have to apply. There's somebody that just did that for MySQL to Jonah Harris, if you remember him. He was MariaDB for a while, so he's not. I don't know whether he's published it or not yet, but he just did the same thing where I think he can make Postgres talk MySQL.
I saw something about that. Yeah.
That's a cool.
I didn't know who it was, but I saw something about that.
Yeah.
Not completely and utterly.
Nextgres, I want to say it's called.
Nextgres.
Is this fun for you guys? This is like a really starting to get esoteric and niche, but it's like my bread and butter. So I'm totally cool to have this conversation as long as we all want to chat about it. I just want to make sure that everybody else. Is there other questions that?
Are there a question about debug? I mean, we're all
Anything
talking about
here.
Postgres forks now.
Yeah, since we're talking about working the storage engine of Postgres, I think we've gotten down in the weeds a smidge. So, but whatever you guys want to talk about.
Do you plan an on-prem version?
We are planning a. We just talked about this today. I can talk about it. Yay! We had an online user group meeting for DBoss today. We are working on dramatically improving self-hosting. So when we first shipped our very first version, it was a TypeScript and it was very much a framework. Like you pretty much had to adopt us lock, stock, and barrel, which is great if you don't have existing code. But it turns out a lot of the potential customers have existing code. So we then started to work, when we built the Python version last summer, we built it more of like as a library. The idea of like, instead of having like, I don't know how much of the JavaScript community and ecosystem but we basically embedded the Koa JavaScript web framework inside of, we built on top of it for DBoss v1. And when we built the Python version, we explicitly built it as a library that could plug into multiple different web stacks. We primarily use Fast API, but it also works with Flask, and I don't know any others in the Python space, but I know it works with more than just those two. So then we updated TypeScript to our v2 API. The previous version, if we looked at the code here a second ago, you'll notice that we have this like intrinsic, well, where'd we go here? You have this global here, the DBoss, the logger, DBoss set event. If we look in the utilities, we have DBoss connects client. So it used to be this information was passed in as a parameter, and so we made a bunch of changes to the API level to make certain things intrinsic instead of explicit parameters, which makes it easier to integrate into existing code. And we made this library available. This actual application is still a standalone framework app. You can tell that because we have our own like HTTP endpoint types of operations. So you can see here, like this is the function you call for /resize. So this is obviously very web API, post, get, et cetera, but as part of the V2, we also modified it so it'd be a library so they can work standalone. In fact, we've got a bunch of work recently where we've been integrating it into popular JavaScript frameworks like Next and Nest. I'm not working on that, but I know that it's going on, so I can't tell you the specifics so much, but these are these like, React-based frameworks that are designed to be primarily static, but have in some ways some kind of server-side code. So like we want to be able to do that, but the server-side code is all DBoS, so that you can do these kinds of transactional, durable, fault-tolerant types of systems with a cool React-y type of front end. And the next thing we hear from customers is, great, we want to run this, we want to integrate your code into our application that's running over here in our data center, in Azure, in GCP, and wherever, right? And so we are currently working on a bunch of infrastructure called I'm not sure if I'm allowed to talk about the specifics of it, but we're working on a bunch of stuff to make it easier to host outside of our cloud. As you can imagine, this is part of the product market fit project of any kind of startup, right? So you start off with, we think this is what the customers want, and then you actually go talk to customers after you build something and you learn the things that they want. And what we're hearing from our customers are, we really, really like how much easier it is to do these transactional, durable workflows, but we need to integrate them into our existing application, so you need to make it easier for us to do that. So we are focused on that right now. I think we'll have something next month-y kind of time.
As far as integrating, so the two things I heard, like when you say integrated applications, languages and then like where it runs. Are there?
This is primarily about the where it runs.
Yeah.
Right now, today, we support TypeScript and Python. And again, see earlier
You had to
comment.
add Python, like, and that was the response of like.
We added Python. Python we have now. I showed this demo in TypeScript, but that exact same demo is available in Python, except the time travel debugger isn't implemented.
Is Golang coming?
Golang is one of the languages that we've been asked about. I don't think at this point we have any public information on our roadmap about supporting any additional languages.
I see. Okay.
Well spoken.
Hmm?
Well spoken.
Yeah, well, I'll be honest, even though I came from Microsoft and I'm a C# guy through and through, I would put my money on Go if I was the one who was in charge of it, right?
So you had, besides location and then like different languages, are there any other sort of like big asks that you guys have gotten as far as like product market fit as you've been talking to people?
I'm not sure. I don't talk to as many customers as some of my, like we have a CEO now, which, I don't think we did the last time I was, well, actually like last fall we did, but, so we have like a whole sales team and marketing team and like we're getting to be like a real company and shit. It's pretty cool. When we started, it was like, when I joined the company, there were, Peter, Chin, Chuck, Max, Minaj. I was number 6, and and Mike Stonebreaker is the CTO, and we had Michael Coden, who was a old friend of Mike Stonebreaker's, who was our like interim CEO, and we had a chairman of the board, and that was it. Like, we didn't have a marketing team. We didn't even We've added 2 engineers since then, but we've added like marketing people and sales people and a CEO and a chief of staff and a whole lot of things that you need to run a company that don't write code. Though Jeremy, our CEO, is the first engineer at Reddit, so he's actually really pretty hardcore guy technical wise. He was at AWS, he was at Netflix for like a bunch of the Chaos Monkey stuff. I don't remember the specifics, but he's he jokes about the fact he doesn't write code anymore, but he's a pretty swift guy. I'm only saying that because I assume he'll watch the video of this all the way to the end, and in case he does, I want to make sure that I'm not talking shit. No, I hope he doesn't watch the whole video, because now he heard me say it's talking shit. Well, if nothing else, I've kept you guys here really long past, like, we're at like 8:10 already, so we are,
Any final questions?
Let's try.
That's fine. Thank you.
true, let's try. Thank you guys so much.